So we're going to do factoring by grouping, and we're going to look at common factoring. So we have 4 terms in this polynomial, and we probably want to look at reorganizing this right now. Normally, let's say if it was a trinomial. A trinomial deals with just 3. We could possibly work with these 3 and maybe factor them and then just have this y squared left over. So we can test that and take a look if this is factorable. And if not, we might have to revert back to just common factoring. And by the title, you can kind of guess that we're probably going to have to do that. But let's reorder this question. When we usually write a polynomial, we write it with the largest exponent first. In fact, what I'll do is I'll bring the y up. I'll have the negative y squared. I'll have that be the first term. Okay. Then we'll have plus x squared. And then we follow that with the next lowest variable's exponent, so plus 2x, and then plus 1. And what we're going to do is we'll just focus on this part to start. And is this something we can factor right here? Let's see. That looks like it might be a perfect square trinomial right now. X plus 1 and x plus 1. I think that'll do it. If we were to do a product sum, so we need 2 numbers that multiply to our c value, which is, or a times c, which is 1, and then 2 values that add to the middle term, which is 2, we can do 1 and 1, and that would work. So here's a possibility. You could have this, x plus 1, x plus 1, okay, and yes, we could do this. In fact, actually, this is going to be the way we're going to do it. So my common factoring was incorrect when I first wrote that. I can simplify this. This x plus 1 and this x plus 1, we can rewrite them as just x plus 1 squared. Okay. Now, what I'm going to do from here is I'm going to use a let statement. I'm going to say let z equal x plus 1. Okay, so what that means is we're going to replace the x plus 1 here with the letter z. Okay, so this is going to read negative y squared plus z squared. Okay, and we'll highlight the z. So the z is what we replace that with. And again, I'm going to change the order. I'm bringing the z first, and I know we're used to writing it kind of alphabetically, but we chose our letter. I could have called it a, and a would have in alphabetical order, so we chose that at random, that variable we used. So now we have z squared minus y squared. Well, these are 2 values that work very nicely with a difference of squares. Do you know that type? Difference of squares, of factoring?
Yeah.
Yeah? Okay. So if we're going to do a difference of squares here, we're looking for the square root of z squared. What does that equal? And we need the square root of y squared. Well, essentially, the square root and the power of 2, they are canceling out. So the square root of z squared is z. The square root of y squared is y. So I'm left with z and y. Z and y when we do difference of squares. And then we just have a plus and a minus in our brackets. The only problem here is the original question didn't have a letter z in it. In fact, it had reference to x. So we need to go through the process of replugging in x plus 1 for z. So we're going to have to replace both the z's with x plus 1. So now, let's see if I have room here. It's going to read, and I'll write this part in red, x plus 1, that's where we replace the z, plus y. Also, we would have had x plus 1 minus y. And then those brackets inside, we can kind of drop them. So you're left with x plus 1 plus y and x plus 1 minus y. And that would be a pretty good form of factor. When I originally looked at this question, I was thinking of common factoring, so I'm going to do it anyways, just to show you maybe another style. Though this one looks like it's probably the best factor form, what we just did. What I was going to do is I was going to rearrange this question. Okay, so I'll rewrite it down here. I was originally going to say f at x was equal to x squared plus 2x plus 1 minus y squared. So I was actually going to break this down into 2 sets of common factoring. I was going to common factor these 2 terms, and I was going to common factor these 2 terms. Well, actually, I was going to factor difference of square of these 2 and common factor this one. So what I was thinking of doing is this could have been a difference of squares here. So this could have been written as 1 plus y, 1 minus y. And then here I could have factored out an x value, and I would have had x and then x plus 2. And this could have been a factored version of it, but you know, it depends. This is probably the best one, the one we had above. I was thinking of this as a common factoring, but as we started going into it, we kind of found a better answer here. Both are technically a factored form, just the one we first did is probably a better form of a factored version.